finish off on one of these guys here, I want you to go ahead and give the next one a shot. But in terms of sort of like guidance for this guy, and I'll pause this and let you kind of work on it on your own, and then we'll come back and work through it. This guy here, start by identifying what the base is. Is it greater than when? Identify whether A and B are positive or negative. And then identify what the H is on these guys here. From that, you should then be able to maybe do a sketch and get an idea of what would the domain be. Is it increasing or decreasing? And then afterwards, you can kind of break it up into two and solve, is there a zero? If there is, what is it? Is there a y-intercept? If there is, what is it? And then at the end, just a reinforcement of what's the asymptote then. Okay? So give that a shot and then on your own, and then we'll walk through it. So I know a lot of you guys have kind of run through this guy already in your own. First things first. Oh, I should probably stop freezing the screen here.
Sir.
Okay.
Can you explain whenever we have to use
I'm going through it right now.
No, but whenever we have to use exponent form or log.
How about I go through it in full and then you'll see one. So from beginning to end here, right, the first thing's asking for is what is the domain of this guy. So if we walk through it, my C value is greater than 1, my A value is negative, and my B value is positive. If that's the case, right, and my H value is 4. What did I just do wrong? Is it negative 4?
Yes.
You sure?
-2.
Or is it -2? Because you had the common factor of the 2 at the front of it. So the B, if the B doesn't have like the brackets around it, then you'll have to keep an eye on that. But that's going to change now what your domain would be, and that was the trick to this guy here. Those are little things, but just be mindful of it. So again, if C is greater than 1, and A is negative, and B is right, well, I would have an H of -2, and it would run something like that. That's important because what it means is that for my domain, -2 to infinity. Remember, domain is just talking where does it exist on the x-axis. It's not whether that's going up or down. Is it going right or is it going left, and then where is it starting? Because of my little sketch, I also know that this guy is decreasing, right? The combo of A and B and C dictates that. Now the next part on this one here is saying, well, what is my 0 in this case? And this is when you're going to start to get into when I start to switch things around. So the 0 is asking, what is x when y is equal to 0? So I write it out. 0, -2, log 4. I'm going to leave it like it's written now because it doesn't matter. I saw how you did it, and you could leave it as the common factored version, or you could do it like this. Either one is fine, right? But in terms of solving this guy now, just like on our like trig function questions, right? We're trying to get rid of like k and a first before we get into that x. Like think about it like that, right? We got the a sine something bxh whatever, and a k. We get those out of the way first. So this becomes -4 log 4 2x plus 4. And then we divide by -2 and divide by -2. So 2 is equal to log 4. And then 2x plus 4. Now, once we've isolated 4, right? Log base bxh. It's really very similar to that trig guy. Well, now is when we switch to exponential form. Because we have an output that is essentially in log form. That's the power. That's what's going to become the exponent.
4 will become the base, and then 2x plus 4 equals like what x.
Yeah, perfect. So basically to rewrite it now, 4 to the power of 2 is equal to 2x plus 4.
And just square it, and then just algebra.
16 is equal to 2x plus 4. And then bring that guy over. 12 is equal to 2x. Divide by x is equal to 6. So in terms of like when do I trigger it, if you want to like add a step in there, Hannah, what I would do is basically as a procedure, get K, get A out of the way, and then you're going to basically take my like the output that I have on the opposite side. I'm going to take the base and I'm going to take like BXH, and then I'm going to rearrange it into exponential form. Is basically the idea. But you can kind of maybe put like steps through it. Move K, move A, switch to exponential form. And then it's just straight solve. Okay? Now, on the last one, if we had just thought about it, we could have saved ourselves some time and decide whether or not there was a y-intercept. May not happen on this guy here, but look at the domain of it. And can you tell me right now, will this function cross the y-intercept?
Yes.
Yeah, it will. So, dang it. Let's actually go ahead and solve for it. So, on this guy here, in fact, let me just zoom in more so I can just use the white space there better. So on this guy here, we're asked to now find what is the y value when x is actually 0. So y is equal to negative 2 log 4, 2 times 0 plus 4 plus 4. So internally you still solve, but we're not going to have a negative sort of value for the combo of bxh. So y is equal to negative 2 log 4. I'm going to have 0 plus 4 is 4 plus 4. Now, here's where it's nice that we kind of did a little bit of the mental math. You can still do the long form, but this is something that should come naturally to you. Right now, what do you think you would solve next? Huh? Yeah. Think about it right now. On the last guy, when we were solving for an x, we work outside in towards it. When we solve for a y, with functions like this, we always work our way inside out.
So how do you do like log 4?
Log 4. So you could do change of base law, change them both to it, and then kind of divide it. But what you would end up with is log base 10 of 4 divided by log base 10 of 4. So if I had log 4 divided by log 4, what do you think you'd get? 1. If you see this guy here, all you have to ask yourself again, just looking at that, what I've highlighted, 4 to the power of what would give me 4? So that's it. That's all you got to do. So now it's y is equal to negative 2 times 1 plus 4. We solved that point, that part. Okay?
That's what you always do for the log, but then the math, it's whatever the bottom is to the power of what is the top.
If it's a whole number, it'll work. These guys here usually kind of flow that way. If not, there's a change of base thing I can show you. We'll get into that later. It should get it a jail-free card, but y is equal to negative 2 plus 4, so y is equal to 2, meaning 0 and 2 is the actual y-intercept. Don't forget at the bottom here, if you wanted to write it out, right, that was 6 and 0. We're talking about zeros and y-intercepts, so writing those guys in, this guy exists, and then the last part was reinforcing where was the asymptote. Technically, you don't have to write it like as the h. When they're actually asking for the asymptote, I wouldn't be so punitive with it. But when they say write out the equation of the asymptote, they mean to write out x is equal to negative 2. Does it mean the same thing when you put h as it? Yeah, like I know what you mean. But in terms of like being specific, the equation, if I were to write it into Desmos, that would make it make sense. But again, I'm not going to be too nitpicky with that because just you writing h is equal to negative 2 is a demonstration of you know what the asymptote is.
If I did H equals.
I was just saying.
Oh, okay.
Yeah, if I just that's the whole thing. Yeah, the technical version would be what would I have to write in Desmos to write out the actual equation?
Okay, well, what if it was an exponential function and you asked for the asymptote? Would we put y equals?
Well, then now, yes, exactly. Thank you. Yeah, yeah. It's the same thing of rad functions too. They'll even go through and say it like the asymptote of this rad is y is equal to. They're hoping you know that that means they just gave you a k, right? But all right, I'll let you try this guy here again on your own. Different in that look towards the C value, look towards the A value, the missing K, and then identify and solve. So, same thing on this guy here. Let's walk through the idea of what is our C value. Well, this guy is, between 0 and 1, so that's going to sort of flip the way our A is traditionally working. The A on this guy isn't shown, but we know he's positive because it just be 1. But our B in this case is a negative value. This one has been common factored out because you see the additional set of brackets. So my H on this guy would actually be positive 3. Why is that helpful? Well, because now I know. That is going to throw things off a little bit. Let's just see here for a second for this. If he's a positive 3 in this case here, and I go ahead and write that my asymptote is that value there, and I know that for something of this nature, A being positive, but for a equation where C is between 0 and 1, we know it's going to be going down and to the left. Yeah?
Down to the right.
But if A is, it's going to be switched, right? You got to look for this guy here. What matters? C is between 0 and 1.
Yeah.
So that means the interaction with A is going to flip it. So it's going to go down and to the right. B is negative, so down and to the left. Okay? That's important for 2 reasons. First reason, my domain is going to be negative infinity to 3. And not including. I got to make sure that I was, in terms of the brackets, okay, they did write them the right way. Okay, just making sure. Negative infinity to 3, because we're going from negative infinity all the way over here, gentlemen. It is a increasing or decreasing. It looks kind of weird, but we always walk left to right, so increasing. Because we're always walking left to right. So yes, it looks, if I were to describe it, I would say the function is going down and to the left.
How can you start from infinity?
And then walk your way up. Exactly.
Is there a increasing or increasing? It's just weird with the arrow going down.
It is increasing.
Interesting, you start from
To describe it, like if you as a human being said, let's describe it, I would say down and to the left. Absolutely. But when we talk about increasing or decreasing,
I think it's because of the arrow is pointing out.
and I only do that as in like pointing down just because I like to. So here, gents, just as a focus here, the reason why I put that arrow there is I know when C is between 0 and 1, then whatever my A value is, it's going to flip it. So in terms of like my knowledge of this, without having to go to a memory aid, this is dictating the A is flipped, so it's going down. The B is negative, so it's going to go to the left. But increasing and decreasing is dictated by, if I was a little dude walking up this function from left to right, am I walking uphill or downhill? Right.
You were once
That's perfect. That's what we're going to use.
What?
I said, if I was a little man, and then went on,
It's a little dude.
little dude, and Jackson, you said,
What do you mean if I was?
if I was. So that, right now, folks, if you get to this point in the video right now, if not,
Bottom of your
yeah,
chest,
I
right?
need
If
at
I was.
least 3 of the people that are downstairs to come to me by tomorrow and let me know that they watched this video.
Subscribe.
I'll give you the weekend. Let's just say the Tuesday after Easter. If one of you come in and have watched to this point here, a big sleeve of donuts from Tim Hortons will be delivered to this class.
Wait,
But
like, how's that gonna work?
Yeah.
Obviously, we're
No,
gonna tell them
for
if
us
it
now
includes us.
too.
The idea is though that if you guys keep your mouth shut and don't tell them about it, you'll get the donuts. Right? But if they, right? So this is the idea. So as long as you guys are quiet and don't tell anything, by Tuesday, I'll try and remember. I'll probably forget on Tuesday morning, but on Wednesday morning,
Wait, sir, who's all gone? I just need to know who's all gone.
just a bunch of them. But regardless,
Because
okay,
if it's
we're going too long. We're going too long. Move it in. It's too much of the video right
I'm
now.
saying Kate is not watching the video. So
Okay, I know, but it's too much of the video. They're gonna wonder what's going on. So
Sorry for that short intermission. That was
sorry for the intermission. For those people that are watching this that don't go to Pontiac High, this is just a aside to try and see if kids are actually watching the video that are away at a tournament. Now, moving on. We have.
watching your video.
I know nobody. I just let me feel. Let me feel something. Feel like I'm making a
People
difference.
who do like it, we don't like it, and then we don't watch it.
Okay, all right, perfect. So, zeros,
Statistics day.
zeros. Okay. I'm gonna set this as y is equal to 0, Hey. and then we've got our log 3/4 negative x plus 3. I'm just gonna do that now. You can keep it whatever way it is. In terms of solving for this guy right now, there is no k, right? There is no a. Don't have to divide by a positive
Wait,
one.
sir, why didn't you put the negative?
I just wanted to write it like that.
Yeah, but
Yeah, but why?
Least
sorry,
now, because then when I
you should, sorry, I didn't mean to say
yeah,
that.
I just distributed the negative throughout,
Yeah.
just because when I get to the next step, it just saves me a step.
Yeah.
So if this is 0, a is gone and k is gone, this is where we switch to exponential form. So we didn't have to move anything around. We've already isolated. So right now, the output, that 0 is our power. The base is still the base, right? That's terrible. Let's do this again. The base is still the base to the power of is equal to negative x plus 3. So in terms of solving it, 3 over 4 to the power of 0 is 1. So 1 is equal to negative x plus 3. And then bring that guy over. Essentially, we're going to end up with x is going to be equal to negative 2 divided by the negative positive 2. Right? So my 0 is going to be 2 and 0. Okay? So the y-intercept guy, okay, we're still going to do y is equal to log 3 over 4 negative x plus 3, but we'll set that x negative 0 plus 3. So could have done it whatever we wanted. I'd kind of changed it ahead of time. So now y is equal to log 3/4, but negative 0 plus 3 is just going to give me a value of 3. Again, if you did it the other way and left the negative on the outside, it would be 0 minus 3. That would leave you with negative 3. The negative times the negative would turn into a positive. You'd still land at the same spot here. So this one's a little bit more challenging, but 3 over 4 to the power of what would give you 3?
Wait, what?
3 over 4, 3/4 to the power of what would give you 3?
Is it 1 over 2?
You could,
It's a negative.
Yeah.
because you're going to be taking it and flipping it around. Yeah, I'll give you some time to think about it for a second. Let me just pause this guy.
What the heck is not big?
So looking at this guy here, can you easily find a number? Because try and think about it. We wanted to logic our way through this one and mental math our way through this one, right? I want to really just keep, what's one thing I could do to 0.75 where I could change, I could leave the numerator alone and then modify the denominator. That's kind of tough. It's hard to think about a number. So these are one of the ones where if you try it enough and you're like, I'm stuck, this is when all of a sudden we go to our change of base rule. So I'll put that here as a star. and say, let's look to change of base. We're going to do this in a way to allow us to spit out the actual correct value, but the change of base stuff is basically just saying if I wanted to take A to B right here and split it off and actually change the base so I can maybe solve it, basically what happens is log 10 of B divided by log 10 of A. If you want to make it so that this guy works, that's kind of your process. It's not, doesn't seem like it makes a whole lot of sense, but if you run that down now and use this logic, yeah. Let me just finish this guy here because you're going to want to see this, and then I'll be done. But change of base law means now then if A, B gets switched up like this, and I don't really have to write the 10. If you know what I mean? It's not necessary, but we'll do it here anyway. So this would turn into log 10 of 3 divided by log 10 of 3 over 4. How would you write that in your calculator? Literally just go log 3 divided by log 3 over 4. You'll notice now the answer it spits out is something really ugly like y is equal to negative 3.8. 3.82. So that is your get out of jail free card no matter what. I do like the mental math aspect of it because if you can quickly solve these guys, right? Log 4. That one should be really easy for you guys to go through and do. Whereas this one, if I'm looking at it going like, I can't think of a number that makes sense for that, I'm just going to use my change of base knowledge for that. So last but not least, we can then say 0 and negative 3.82. We can for here say that x is equal to positive 3, and then that would be done for this guy here. I will give you the next 10 minutes to start to walk through, and I'll leave that back with you for a second, but and sketch the asymptote, tell me the domain, state the range of these guys, state the y-intercept if one exists, blah, blah, blah. We'll go through here. We'll talk about G, and then we'll talk about the inverses there as well. So let's dive into that next. Okay, I'll just do the first two here in terms of like what's our domain and what's our range and talk about that. Sketch including asymptote. So what do I really care about here is let's start by identifying that C is greater than 1. Let's identify that A is negative, that B is negative, and that my H value in this case, because the negative one's been common factored out, H is 4. Okay, and it's a positive 4. So all that to say, sketch the asymptote. So X is equal to 4, or H is equal to 4, whatever you'd like to write it out as. Knowing that C is greater 1 and that A is negative and B is negative, we will know that it is going down and to the left, right? I do that arrow there again as a defining if A and B are negative. That's the way I would draw it out. But we could put arrows on either end of this when we're done. Why is that important? Let's talk about the fact that this guy has an actual domain of negative infinity to positive 4. But because it's going a bit on a diagonal, because we have this guy and the only real barrier is the actual H value, this guy right here is just an element of real numbers or negative infinity to infinity. So you could put YER, you could just put the R symbol, you could write that guy there, that's basically it.
Hated that.
Okay? Either one's acceptable.
But sir, wouldn't infinity be included?
You can't include infinity.
Yeah,
No,
you can't,
that one rule.
you can't include infinity because you can never reach it. It's not an attainable number.
But that's like saying you can't go past infinity, but infinity is forever, so you just constantly be in infinity.
You can't hug infinity.
Let's talk about this later. I'll give you a little more time to do these guys on your own, and then we'll get down to it. Get after it. All in one, and not run out of time. So state the y-intercept of one exists. What I want to say when you're solving for a y value on these guys here, so the actual value of the function, or I'll just keep my thing here, -2 log 4, -1, x minus 4 plus 3. So if I replace that guy there, the x value with a 0, because we are looking for the y-intercept, I want to know what it is when x is 0. So there's my function. With these guys here, if you want, right, I would write out, this is true of any y, I always work inside out. So what do I mean by that? Y is going to be equal to -2, leave that alone, log 4. Internally here, 0 minus 4, just going to be minus 4. -1 times -4 is going to give me positive 4, which is good because now I know that definitely one exists. Not only because the math tells me right here, but so did my diagram, right? So I validated it now, my knowledge of that. Internally, this is just like that other one. I said work inside out. So we're not really worrying about the A or the K yet. Log 4 to the power of 4. Ask yourself, 4 to the power of what gives you 4? That's another one with 1, right? So -2 times 1 plus 3 is going to give us here y is equal to -2 plus 3, y is equal to 1. So the y-intercept of this guy would be 0 and 1. Okay? 0 and 1 in the end of it. State the 0 if one exists. We'll walk through the same kind of procedure there and use y is equal to -2 log 4 -1 x minus 4
Sorry, we just changed to negative x.
plus 3. And yeah, I did that on the last one too. So 2 things I would start out with. Let's change him and let's change the internal brackets so that it works more. Where I'm setting him to 0 right off the bat. I'm going to go -1 times x times -4 and end up with just -x and then plus 4 right off the bat, and then get rid of that extra bracket there. So that at least now things are a little bit cleaner. This is more of my personal preference. You can choose to do whatever you want. These guys here, I would then suggest you are going to work your way basically outside into that x value, and your priority is get rid of that guy, get rid of that guy there. So essentially you're going to bring the 3 over and then you'll divide by -2. So that should be pretty simple. Where we end up with -3 divided by -2 is equal to log 4 -x plus 4. I'll get rid of those guys in here, but we can maybe highlight those guys. These are our focuses in this instance. And the negative and the negative, we just basically cancel each other out. So now I got 3 over 2 is equal to log 4. So what does it trigger now? A is gone, K is gone. Let's take this and turn it into an exponential form. So 3 over 2, I have that guy as my power now. 4 is still the base. And then my output ends up being -x plus 4. So as I go to write it now, this turns into 4 to the power of 3 over 2 is going to be equal to -x plus 4. Now we can just solve, do that exponent, right? So cube it and then square root it. I'll put that up there, Jim. So if you cube it, 64, square root it, I get 8, right? Or you could just put it in your calculator and it'll do it for you.
I just did it to the power of 1 by 5.
Yeah. Either way, at least you know too, though, right? So this guy here ends up becoming 8 is equal to -x plus 4. Bringing that guy over, I have 4 is equal to -x. So -4 is equal to x. So that's going to be my x-intercept, or 0. That one took a little bit more work on those guys there. we can use the same procedure for g as well when solving for an x, but I won't get into that guy right now. State the 0 if 1 exists. We said this guy here is going to be -4 and 0. I put that one down. The equation of the asymptote we know is actually in this case going to be the +4. So x is equal to 4. This one I'll have you just try on your own. But let's talk about, to wrap things up, stating the equation in standard form of the inverse. So there is a memory aid sheet that you can take a look at that does give you an example for this. So if you want to go to that document that I provided to you guys, this guy here, you can actually see a breakdown in steps of taking something from exponent form and going into log form, but the same is true of like the alternate, which we're going to do here. We're going to try and take this guy and put it into exponential form. So this is a good example for us to have. So we've got y is equal to -2 log 4 negative x plus 4 plus 3. Okay. When we talk about inverses, what are the things that are switching in this case? My x and my y. You can make some assumptions in this case too, right? And when I say you can make some assumptions in this, if I were to ask you right now, if the h is +4 and the k is 3, when you do this at the end, what should my h and k be of the standard form exponential function guy? Right? If I swap them, x's and y's are swapping, what's this become? They just switch places, right? So +3, +4, they just switch places. But let's walk through the actual idea of what is happening here, and let's see what skill set we can kind of develop. Everything switches. So this just becomes y, x, right? So for this inverse, we're swapping things out, then we're going to move it around and see where we go from there. So doing this first, that -2 log 4 minus, that's all one block now. Let's take a look at the 3 here. Let's get him out of the way. X minus 3 is equal to -2 log 4. So you're noticing some patterns here where it's looking similar to what we were doing when we were solving for like an x value. And why is that? It's because we're trying to isolate for y. So the same skills we use when we're trying to solve for x are going to come into play to this guy here. What do you think you would do next then if that were the case, if we were working our way into the y value? Divide by 2. Divide by 2, and -2. Now, I wouldn't leave it like that. To write this in a way that maybe may make more sense for us with an equation would be to now say this is -1/2 times x minus 3y, because now I have something on the exterior, potentially a b, and I have my x and I have my h. So it's written in a way that makes more sense to me later on, right? So is equal to log 4 -y plus 4. At this stage of the game, if we were solving for x, you would now have an output on the other side. You would have a knowledge of a base. You would have you would have the power on the other side. You would have knowledge of your base, and then you would have knowledge of what the output would be if we converted this guy to exponential form. So the first thing that I would suggest that you do is just take this guy here and put him on the other side. I'm going to set my actual base there, and then to the power of -1/2 x minus 3. Hey, now I got something that looks more like an exponential function. Let's bring the 4 over. -y is equal to 4, -1/2 x minus 3. I subtract the 4, I now have a k, right? Which, wait a minute, the y isn't by itself. I knew I started out with h is 4, k is 3. I was hoping they swapped. Right now I have h is 3. That works. But k is negative 4. However, if I divide everything by negative 1, right? Y is going to be equal to, this becomes a negative value. The rest of that all stays the same. And this becomes positive. So there's your standard form inverse if you wanted to. And you could even go so far as to write negative 1 out in front of that as an A value, and then 4 as a clear C value. But that would be the final product of converting it to its inverse standard form, which is a exponential function. Really and truly, it's just the same skill set we use to solve for x. But that is it in a nutshell.